Okay, this is a review of Hess's law and standard enthalpies. Now, this problem that's given is a pretty tough problem, so please be patient as we go through this because it's not necessarily going to be the easiest situation. But if you're good at algebra and solving simultaneous equations, it's very, very similar to that. So this is what we want to do. It gives you some half reactions or some stepped reactions, but it wants you to find out what the heat of formation of this final reaction is. So the goal is to be able to add these three reactions in such a way that you end up with this exact reaction. So we want to be able to find a scenario in which you can rearrange these other reactions and also keeping the enthalpy of reaction consistent with what we're doing and end up with this. So our goal is to get this as your answer. This is your answer and these are your parts. So I'm going to call this first reaction reaction A. I'm going to call this reaction B. And I'm going to call this reaction C. That's simply to keep track of what we're doing. Now if you look, our product of what we want is dinitrogen pentoxide. Well, dinitrogen pentoxide is only in reaction B. It's nowhere else. So in order for it to become a product, that's what we want, right? This is our goal. We're going to have to reverse reaction B. So I'm going to reverse reaction B. Now when I reverse a reaction, you also have to reverse the sign. So I went ahead and put my product for reaction B as my reactants, and my reactants for reactant B as my products. So I switched it around. Well, if this is an exothermic reaction going in this direction, it's going to be endothermic going the opposite direction. Well, I'm closer, so now I have one of my products that I want. But look, I'm making 2 moles of dinitrogen pentoxide here, but I'm only making 1 mole in this reaction. So this reaction is going to have to happen twice. So I'm going to double this reaction so that I can get closer to my final product, what I'm trying to do. When I double everything in the reaction, I'm going to double my 2 to make it 4, my 1 to make it 2, and double my 1 to make it 2. When I double that, that's also going to mean double the heat. So I have to double anything I do to the reaction over here, I also have to do to my enthalpy over here. So now my B is in good shape because now I've got the product that I'm looking for. So that part's good. But now I got to get rid of this water. See, this water is a product, so that means that I need to be able to use one of the other reactions to get rid of water. Well, the only other reaction that has water in it is reaction A. So I want to get reaction A to cancel out this water so it'll go away because I don't have water in my final product. So here I have 1 mole of water on the product side, and here I have 2 moles. Well, I want to get rid of the 2 moles. So the first thing I'm going to do to get rid of this 2 moles of water that I'm stuck with at this point is to go ahead and multiply reaction A by 2, okay? I want to multiply reaction A by 2. So this represents multiplying reaction A by 2. So I multiply through by 2 because I want to get this 2 waters. Well, when I multiply reaction A by 2, I'm also multiplying the enthalpy times 2. So this is also multiplied by 2. Well, I'm getting closer because I have this, but I have it as a product and I really want to get it over as in the reactant side so I can get rid of it. So I'm going to do that. I'm going to reverse my reaction so that, I'll keep my final here, I'm going to reverse my reaction A so that my water is now on this side, okay? So I have 2 moles of liquid water making 2 moles of hydrogen and oxygen. So I just flipped my reactants and my products here, and I also flipped the sign of this. So I'm getting closer, because if I added this reaction to this reaction, this water in my product and this water in my reactant would cancel, all right? But then look, I would have this nitric acid over here. Well, there's no nitric acid in my final product. I got to get rid of this nitric acid. It's kind of like a very multi-stepped process. Well, nitric acid is in reaction B, so that's going to help me, or C, excuse me. So I'm going to get rid of this nitric acid. So what I do is I'm going to take reaction C and multiply it by 4 so that I can have 4 nitric acids. Well, why do I want to do that? Because there's 4 nitric acids over here I need to get rid of. So I do that. I multiply reaction C by 4. So everything is multiplied by 4, including my enthalpy. So my enthalpy up here was negative 174, and I'm multiplying it by 4. Thank you for your patience. Hang in there. We're not quite done, but we're getting closer. So now I'm going to go ahead and add my 3 new reactions together. This is all the things that I've done. When I took reaction A and reversed it and multiplied it by 2, this is what I got. When I took reaction B, reversed it, and multiplied it by 2, this is what I got. And when I took reaction C and simply multiplied it by 4, this is what I got, including my enthalpies. Now remember, Hess's law says that if you add these reactions together, these stepped reactions, you can also add this together, and this will give you the enthalpy for the final reactant, or the final reaction. So this is what I'm doing. These 2 waters are on the, you can think of this as kind of like an equal sign. These 2 waters are on the left, and they cancel with the 2 waters on the right. Okay? These 2 hydrogens are on the left, and they cancel with the 2 hydrogens on the right. These 2 nitric acids, or 4 nitric acids on the left, will cancel with the 4 nitric acids on the right. Now I have 1 oxygen over here and 6 over here. So if I have 6 on the left and 1 on the right, I can subtract 1 out, and I'll be left with 5. Okay, so I'm left with 2 nitrogens in gas, 5 oxygens as gas, and on this side, the only thing I'm left with is 2 moles of dinitrogen pentoxide. So if I go back to my original problem, that's the actual problem that they wanted. 2 nitrogens, 5 oxygens, and 2 dinitrogen pentoxides. I took all my enthalpies that I had used after manipulating them, whether I reversed the reaction or added or multiplied by 2 or 4 or whatever. When you add all of these up, you'll get 28.4 kilojoules, and this is your answer. Now that was a long problem, and it was pretty involved, and not all problems are like that. That's essentially what Hess's law is telling you to do. Let's do a couple more examples. Okay. All right. Let's look at 22. I thought I had another one, but maybe not. Okay. All right. Oh, I guess it's 21. It's mislabeled. Okay. So here is another reaction or another formula that we use in thermochemistry. If I want to find the standard heat of formation, standard, this little dot up here means standard, and that's the same thing as saying at standard temperature and pressure, okay? The standard heat of formation of this whole reaction. Now you're going to use either Appendix A in your textbook, or you can use, you can Google a lot of these, or you can have a chart. So there's several different ways to get heat of formation information for different products. And so like in this case, Appendix A, it has the standard heat of formation for several different products. And it also tells you what state it's in. So S is for solid, and G is for gas, and L is for liquid, and AQ is for aqueous, that kind of stuff. But there also are many charts that are published out there, and it'll tell you, for example, the heat of formation of certain products. Okay, so if it would always be provided for you on a test or a quiz. You would always have a table with that information. The trick is to make sure you're using the right phase. So I've looked these up on a table. Now, on my table, it had this value, and in the book, it had this value. Honestly, when it's all said and done, the difference between here and here is not going to make a difference. So when you look up these values on the table or on the chart, I had to Google this one because it was not in the book as the correct one. It only had the gas form or the solid, not the liquid. All right, so remember our equation. You want to find the heat of formation of the products, that's over here, and subtract the heat of formation of the reactants, and those are over there. So my products are silicon dioxide. Now, why is there a 4 here? Because I have 4 moles of hydrochloric acid in aqueous form. So I had to take the 167, or negative 167, and multiply by 4. I'm subtracting the heat of formation of the reactants. And so silicon tetrachloride, there's only 1 mole of that. 2 moles of water, so we have to multiply by that too. Now be careful because you're subtracting all of the reactants. Okay, so keep those signs organized, otherwise you'll get confused. So this means stayed the same. 4 times the negative number gave you this. This stayed the same. 2 times the negative number gave you that. Now a negative plus a negative is going to give you a negative. Okay? But be careful because when you have a negative number minus another negative number, you're going to be adding them together. When you're all said and done, you get this answer here. All right, so let's look at the next one. It's a similar one, then we'll be done. Okay? So we're going to assume that this is balanced and use this reaction the way that it is. I'm not sure if it is, but we're just going to assume that. Okay, we're using the same formula. The heat of reaction, or the standard heat of reaction, is going to be the heat of formation of the products, which are over here, minus the heat of formation of the reactants. Again, you get these off of charts, okay? And I just made it more clear here that when you look at nitrogen dioxide gas, you get this number, but you're going to multiply it by 4 because there's 4 moles. You're going to take this number and multiply it by 6 because there's 6 moles. This number and multiply it by 4 because there are 4 moles, and oxygen is 0, so you can multiply it by whatever you want, you're still going to get 0. So our products are 33 times 4 and 6 times negative 285. I'm subtracting my reactants, and I have negative 45.9s and 0. Be careful with your signs. This becomes a negative number plus this number because it's minus a negative, and you should get this value. Good luck.